Hey everybody, in this video we are hopefully going to do all four of them. Unless I feel like it's taking too long, then I'll split it up into two and two of the examples you see on your screen right now, which is we're going to be evaluating these trig expressions, but we're going to be doing so using the indicated identities. So the first two are asking us to use sum or difference identities. Obviously there's more than one way to do it, but either way, whatever way you do a problem, you should get, if you get the right answer, it should all be the same answer. Okay, so looking at the first example, when you're using sum and difference identities, and the denominator will typically be 12, right? My best advice to you is, when you're dealing with this whole alpha plus beta, or perhaps alpha minus beta, is to at least alpha. Maybe it'll turn into beta if you end up subtracting, but I'd say more often than not, you could just leave it as alpha. You're going to use pi over 4. Okay, I promise you, by doing this, you'll be in good shape. Multiply on top and bottom by 3 to get the common denom, and that's 3 pi over 12, okay? So always pi over 4 if it's in radians, or 45 degrees if it's in degrees. Make one of the angles this. Now, if alpha is pi over 4, which is 3 pi over 12, I need to know then what would beta be? Alpha plus what? 3 pi over 12 plus what will equal the angle in question, which is 11 pi over 12. And hopefully everyone is able to figure out that that would have to be 8 pi over 12. And if I reduce 4 on top and bottom, that would be 2 pi over 3. Just carefully you don't mess up. So then that is beta. So this is for this question right here, okay? So alpha, we're going to use pi over 4. Beta, we're going to use 2 pi over 3. If I add these two angles, I get 11 pi over 12. 11 pi over 12 is not in the unit circle, so we have to use an angle sum or difference identity, which can then find us the exact answer without using a calculator at all. So from here, cosine of alpha plus beta. What is that identity? You should know by yourself. It's cosine alpha, cosine beta, minus, cosine is the opposite sign, sine alpha, sine beta. Way to remember is you got your cosines, your opposite sign, and then the sines. Cosine. See it? All right, from there, we're going to fill in our alpha and our beta. So that means you have cosine of pi over 4, cosine of 2 pi over 3. And in the last two videos, we just practiced evaluating a bunch of these, or 3 videos even, minus sine of pi over 4. If you don't realize, like, everything just builds on top of each other. If you don't know this skill, the next skill is harder, and so on and so on. Sine of 2 pi over 3. Next, the cosine and the sine of pi over 4, as we saw just recently, it's root 2 over 2. That's our medium, right? Root 2 over 2. Say 2. It's a little sloppy. Times, minus. Okay. Now we have 2 pi over 3, tall and skinny like a tree. 2 pi over 3 is the angle right up in there for, do I mind the paint or something on my hand? 2 pi over 3 is up over there. So cosine is left a little, and then the sine is up a lot. So left a little for cosine, that's going to be negative 1/2, times up a lot, root 3 over 2. There we go. That means this is negative root 2 over 4, not 2, you multiply the bottoms, minus root 2 times root 3 is root 6 over 4. And for the final answer for this whole thing, I would say you should write it with one denominator, negative root 2 minus root 6 all over 4. If it's multiple choice, maybe they factor out the negative and you have root 2 plus root 6 on the inside. All over 4, both of those are the exact same answer for numero 24 above. Okie dokie. So those are both good, or you could have negative root 6 minus root 2, you know, obviously commutative property to whatever degree is appropriate. Next example. Same idea, but it's tan, so we're going to use a tangent angle sum or difference identity. Again, sum. The only time I really use the difference identity is if the angle is, maybe if it's negative, or if it's like pi over 12, because then I'm going to subtract to get 1 on top. But anyhow, 23 pi over 12. So again, if I use that alpha is 3 pi over 12, again, because that's pi over 4. 3 pi over 12 plus what? Well, beta would have to be pretty easy, 20 pi over 12. Now, what do these reduce to? Again, we said that's pi over 4. This, divide by 4, we get 5 pi over 3. Ooh, I wasn't on the screen. Forgive me. So there is your alpha, and there is your beta. So I'm going to do the angle sum. So tan of alpha plus beta equals, so the identity, The top looks like you're distributing. You aren't. That's not a thing. It just looks like it. And then the bottom is 1 minus the product of tan alpha, tan beta. So same answers there. Now we're going to clean this up all the way, but let's see. So alpha is pi over 4. So I'm just saving some space here. That's pi over 4. That guy is 5 pi over 3. Now before I even write it down, the tan of pi over 4 is right there. Tan of pi over 4 is 1. So I'm going to get a 1 here. I'm going to get a 1 right there. The tan of 5 pi over 3, tan of anything over 3 is root 3. So if you could do it where you have 5 pi over 3, that's great, because if you have something over 6, so if I were subtracting, I could use 6, pi over 6 type of angle, where pi over 6 is the reference angle. That means you're going to get root 3 over 3. You're going to have a compound fraction. There's an extra layer of simplifying that's going to be happening, but, you know, you get there. So 5 pi over 3, well, so I'm just going to look at tree. 1, 2, 3 pi over 3, 4, 5 pi over 3. 5 pi over 3 is over here in quadrant 4. Tangent's negative there, so it's negative root 3. So again, you have tan of pi over 4, which is 1 in the next step, plus tan of 5 pi over 3, which is negative root 3 in the next step. So when I write the next step, I'm going to just write minus root 3 over 1 minus opposite sign on bottom. So it's like sine over cosine. Sine keeps the same sign. Cosine gets the opposite for this. So tan pi over 4, again, that's 1, but it doesn't subtract with that 1. That 1 multiplies here. That's together. You can't subtract 1 minus 1, okay? Tan of 5 pi over 3. And that was negative again. So 1 times negative root 3, that'll become plus root 3. Really, you should get, when you're done with these problems, doing it the way I'm showing you, you should get 1 plus something, 1 minus something. 1 will be plus, 1 will be minus on top and bottom. Okay? If they're both the same thing, you messed up. Okay? Equals 1 minus root 3 over 1 minus 1 times negative root 3 becomes plus root 3. So like I said, when you're doing a tangent type of problem like this, this should always happen. If it's not happening, you're doing something wrong. Okay? Now to simplify something like this, what you do is you multiply by the conjugate of the denominator. You would FOIL. When you FOIL conjugates though, the outer and the inner will always cancel out, because one will be plus, one will be minus. But on top, they're not conjugates of each other. They're the same thing. You have to properly FOIL, and some of you really have to slow down and write down some steps, okay? Okay. And also, what is the deal with, like, you think you're too good for parentheses? Because it means something totally different without parentheses. Stop thinking it's cute to write it without parentheses. That is terrible. It means something else. It doesn't mean what you think it means. You crazy. Don't do that. Okay, if I FOIL, I'm unfortunately diving into this. First times first is 1. Minus root 3, inner is minus root 3, so it's minus 2 root 3. That's how you combine those, in case you're not sure. Negative root 3 times negative root 3 is positive 3. 1 plus 3. This minus has nothing to do with this 1 or this 3. That's negative 2 root 3 is for itself. So the top is going to become 4 minus 2 root 3. Anyhow, bottom. 1 times 1 is 1. Outer is negative root 3. Inner is positive root 3. Those are gone. And last times last is minus 3. So the bottom is negative 2. And then the way you do this, pretzel it. I'm not like leaving something out. I just circle sloppy. 4 over negative 2 is negative 2. Negative over negative is positive. 2's crossed out, root 3. So maybe the answer is written like that. Maybe it's turned around, root 3 minus 2. Either one of these, they are the same exact answer. Okay? So that is the end of this one. This is already 9 minutes, so I'm going to stop here. I'm going to do the next two in a separate video. So this video is a focus on the sum and difference identities. We did an example with cosine. We did an example with tangent. If you have to do an example with secant, cosecant, cotangent, you could just do one of the others and then flip it, reciprocal, rationalize your denominator, you know, whatever. So just remember to do that at the end. Don't forget. Thumbs up if you are a rock star. Thumbs down if you're a Krabby Patty and you don't know what you're doing and you're still confused. Questions, comments, concerns, requests in the comment section. Adios for now.